Students, coming to the next topic, that is a dining philosopher problem. So this is one of the classical problem in synchronization. So I already explained about the classical problems of synchronization, about readers and writers problem, bounded buffered problem. Now coming to the third technique, that is the dining philosopher problem. So what exactly this dining philosopher problem? First let me write the points. So let us take the 5 philosophers. So this is one of the important topic. Please be alert. The 5 philosophers are sitting around a circular table. Let us take a circular table. So the 5 philosophers are sitting in the circular table. Okay. So let me try that. So this is a table. So in the table you are having a food in the middle. So 5 philosophers are sitting in the table. So the philosophers, let us take P0, P1 and P2, P3, P4. So these are the 5 philosophers sitting around the table in a circular table. Next, in the dining table has 5 chopsticks and bowl of rice in the middle. So here you are having the chopsticks. You take the chopsticks. This is the F0, F1, F2, F3, F4. So 5 chopsticks, and in the middle food is there. And next, here the philosopher either eat or think. Philosopher either eat or think. If one philosopher want to eat, he has to pick the 2 forks from left side and the right side. If he wants to eat, he has to pick this fork and this fork, because at a time it has, if he wants to eat, he has to take the 2 forks, then only, or 2 chopsticks, then only he can eat the food. So without the help of 2 chopsticks he cannot eat the food. Okay, so with 1 chopstick he can't eat, so he want only 2 chopsticks. So whenever he is taking these 2 chopsticks, this philosopher has to wait and this philosopher has to wait. Okay, so that is a problem here. The philosopher either eat or think, or else when philosopher wants to eat, he use 2 chopsticks. So these are all the conditions that you have to write while you are solving the problem. He wants to eat 2 chopsticks. When he wants to think, suppose when he wants to think, he keeps down both chopsticks. So whenever he is eating, whenever he is eating, whenever the philosopher wants to eat, okay, he uses 2 chopsticks. Whenever he wants to think, he keeps down the chopsticks. Thinking means keep down. Eating means he has to use the 2 chopsticks. Now let us see how I can, what is the problem exactly here? The problem is, develop an algorithm. I have to develop an algorithm where no philosopher starves. Means he is not supposed to wait for a food. No philosopher starves. That is, every philosopher should eventually get a chance to eat. So let me write the initial solution. Now I'm taking just an initial solution. So if I solve the problem with initial solution, then there is no problem to go for there is no chance to go for the sum of us. So let me solve the problem without taking the sum of us values. So let us take the chopstick initialized to chopstick 5 initialized to 1. Okay, and now I'm taking okay, let me take the sum of us only. Even though if you take the sum of us, what is the solution I'll get? Let's see. This is the initial solution I'm taking. The structure of philosopher I. I'm writing the structure of philosopher I. So here I means I may be any of the philosopher. 1, 2, 3, 0, 1, 2, 3, 4. Any of the philosopher. Do, weight, chopstick of I, and weight, chopstick of I plus 1 modulo 5. Okay, and I have to perform the eat operation. Next, signal chopstick I, signal chopstick I plus 1 modulo 5. Now I have to think. The philosopher has to think. This will perform while everything is true. Okay, so this is the algorithm. So what we are doing here? So the weight chopstick I means the I first I initialize to 0. Okay, the philosopher. Suppose I am taking the chopstick I means fork. The chopstick, that is a fork, is F0 I am taking. Okay, I is 0, F0 I am taking. So next, what fork I have to take? Which fork I had to take? That fork has to be placed in weight state. Then only the other philosopher will not take that. So this is a philosopher 0 I am taking, that is a P0. So the weight F0, and here I plus 1, that is a 0 plus 1 mod 5, indicates 1. So next I had to take F1 fork. So the philosopher 0 has to take F0 and F1 fork, and he has to eat. Whenever he completed his eating, now the signal F0 means that is a 0, increments to 1, and this is F1. It releases, means the signal is going to be release the locks. The signal is used to release the locks. So other philosopher can take. Next time P1 will take. Next time P2 will be take. Like that, they are in a mutual understanding. All the philosophers are mutual understanding. So this problem may go for deadlock also. How it go for deadlock? Okay. So I had used the sum of us values. I said the sum of, even though you are using the sum of us values, you may enter into the deadlock state also. So deadlock state means, suppose if all the here the philosophers are there, P0, P1, P2, P3, P4. The 5 philosophers are there. So all philosophers are independent to each other. Means they are not dependent on the another philosopher. So all the philosophers will take one fork at a time. So he has taken this fork, F0 he has taken. Okay, he has taken another fork. All philosophers have pick one fork at a time. So the P4 philosopher is waiting for P0 to release. Okay, he has taken this fork, he has taken this, and he has taken this, and he has taken this, and he has taken this. Okay, like that they are taken these forks. So the P0 is waiting until the P1 is released. So whenever the P1 is released, then only he can eat this rice. And the P1 is holding this fork and he is waiting for P2 to release the lock. And he has to wait. And here the P3 is taking this fork, and he is waiting for this this fork to eat. So here everything is in deadlock state. Everyone is in deadlock state. So let us see what is the solution for this dining philosophers. How can I solve this deadlock condition? So that I'll explain in the next video. Thank you.